Okay, today's title is Probability Part 2. I want you to recall that the probability of event A equals the number of favorable outcomes over the total outcomes. Make this bold for you. There. All right, so sometimes the sample space is too large to list. When it is, we need to use our counting techniques. Example 1. A poker hand consisting of 5 cards is dealt from a standard deck of where was I? Okay. A poker hand consisting of 5 cards is dealt from a standard deck of 52 cards. Find the probability that the hand contains 5 cards of the same suit. So if I were to sit here and list my sample space, it would just be way too large. So I can't do that. So what I'm going to do is I want to figure out how to find 5 cards of the same suit. How many suits are in a deck of cards? 4 times, I didn't tell you rank matters, so we're going to be using combinations. How many cards are in each suit? 13. And how many are you picking? 5. So where I got this from, there's 4 suits, there's 13 cards in each suit, and I'm picking 5. Over the number of total outcomes. Well, total outcomes, combination, 52 cards total, you're picking 5. Okay? So when I type this in my calculator, I do 13 combination 5 times 4. And then I do 52 combination 5. And you don't have to worry about simplifying these fractions. I actually prefer it if you leave it this way. It's just easier for me. All right, so you get 5,148 over 2,598,960. Example 2. I want to know the probability of getting an ace, king, queen, jack, and 10 of the same suit, which is a royal flush. All right, so how many royal flushes are in each suit? Well, there's an ace, king, queen, jack, and 10 of hearts. There's an ace, king, queen, jack, and 10 of spades. There's one in diamonds, and there's one in clubs. So there's 4 total. There's 4 total royal flushes that occur. And then I have combination 52, choose 5 as your total outcomes. There's only 4 possible royal flushes, and then there's this many total outcomes. So 4 over 2,598,960. And like I said, I want you to leave the fractions like they are. Please don't try to simplify them. All right. Example 3. A couple intends to have 4 children. Assume that having a boy or a girl is an equally likely event. List the sample space of this experiment. So this is kind of a pain in the butt, but we have to list the sample space. So you could have 4 boys, or you could have 3 boys and a girl. And I'm not even kidding, you do have to list them. 2 boys, a girl, and then a boy. A boy, a girl, a boy, a girl. A girl and 3 boys. All girls. 3 girls and a boy. 2 girls, a boy, and then a girl. A girl, a boy, and then 2 girls. A boy, girl, girl, boy. Boy, boy, girl, girl. Girl, girl, boy, boy. And then there is girl, boy, boy, girl. And girl, boy, girl, boy. And boy, girl, girl, boy. Now I have one on here that's a repeat, and so I know I missed one, but what I'm going to do is I'm going to go ahead and tell you that if you're going to have 4 children, how many choices do you have for the first child? 2, either a boy or a girl. How many do you have for the second child? 2, either a boy or a girl. Third child, 2, either boy or girl, and 2. And that would be 16 outcomes, so you make sure you have 16. I don't think I'm right. 1, 2, 3, 4, 5. 5 times 3 is 15, so I'm missing one, and I'm not sure what it is. So we'll deal with that when you come to class, so you can help me find my mistake. All right, example 4. An American roulette wheel has 38 slots. 2 slots are numbered 0 and 0, 0, and the remaining slots are numbered from 1 to 36. Find the probability that the ball lands in an odd number slot. All right. So, how many odd numbers are between 1 and 36? Well, the answer is 18. Half of the numbers are odd. 1, 3, 5, 7. There's 18. Over the total amount of outcomes, well, how many slots are on a roulette wheel? 38. So 18 is favorable because 18 are odd. And 38 is the total number of outcomes because there's 38 slots. There's 36 that are numbered and 2 that are 0 and 0, 0. So that is 38. All right, a monkey is trained to arrange wooden blocks in a straight line. He is then given 11 blocks showing the letters A, B, B, I, I, L, O, P, R, T, Y. What is the probability that the monkey will arrange the blocks to spell the word probability? So you put the number of favorable outcomes over the number of total outcomes. Well, there's only one way to spell probability. Probability. So that's 1 over the total number of ways you can do that. All right, so you need to figure out the number of ways you can arrange this. So you put the total number of blocks on the top over each piece. There's only one A, so you don't have to write that down. 2 B's, 2 I's, and then you don't have to write the rest down. So you need to find that number because that's going to be what goes in the bottom. I'll do it in my calculator on my here because that messes it up. All right, 11 factorial divided by 2 factorial, 2 factorial. And you get over this number. All right, so what this means is there's one proper way to spell probability out of the 9,979,200 ways he could arrange the blocks. Now remember, this is what you do if you have letters that repeat. My B's repeated and my I's repeated, so I had to take that into account. And that's all I have for you.